1 upon h2 del upon del u2 e2 cap plus 1 upon h3 del upon del u3 e3 cap. So this is your del operator. This is another vector operator in your orthogonal covariance system. Okay. Now let us see what will be the form of divergence of a vector in orthogonal covariance system, covariance coordinate system. So we can write the vector field A vector in orthogonal coordinate system like this. A vector can be written as just like we write in a XYZ coordinate system. In our XYZ system, we write our A vector as I cap some coefficient or the component along X. We can call it A, you can call it AX or A1, whatever you are comfortable with, and A2 E2 J cap plus A3 K cap. So this is your vector field in orthogonal. This is your vector field in Cartesian system. So in orthogonal coordinate system, instead of I cap, you can write your unit vector E1 cap. Instead of J cap, you can write your unit vector E2, and similarly for instead of K cap, you can write your E3 cap unit vector. So like this, you can express any vector field in a orthogonal curvilinear coordinate system. Okay, you can express any vector field in an orthogonal curvilinear coordinate system using the unit vectors E1 cap, E2 cap, and E3 cap. And A1, A2, and A3 are a function of U1, U2, U3. Similarly, A2 is also a function of your coordinate variables. Okay, in this orthogonal curvilinear system, A3 is also a function of your coordinate variables U1, U2, U3. Now, therefore, when you are going to take a divergence of that vector field, you can express it like this. Considering the analogy with your Cartesian system, you can express it like this. And divergence of a vector, the first term, second term, third term. So individually, you can split into divergence of the first term, divergence of second term, divergence of a third term. Okay. Now, our next objective is to obtain the form of this divergence of A1, E1, and also similarly divergence of A2, E2, and divergence of A3, E3. If I can obtain the mathematical form for all these things, then I will be able to write divergence of vector in orthogonal curvilinear coordinate system. Now, we can consider the coordinate surfaces that I already discussed. U1 equal to C1, U2 equal to C2, U3 equal to C3. And we can take a gradient on that. So gradient of U1 will be, see here, your gradient formula is this. Instead of gradient of phi, if you take gradient of U1, gradient of U1 will be 1 upon H1 del U1 upon del U1, U1 cap plus 1 upon H2 del, instead of phi, you simply put your U1 del U1 del U2, E2 cap plus 1 upon H3 del U1 del U3, E3 cap. You know that U1, U2, and U3 are coordinate variables, just like in the case of X, Y, Z, they are independent. So del U1 upon del U2 is 0, del U1 upon del U3 is 0, del U1 upon del U1 is 1. This is simply 1. Okay. So your grad of U1 will be equal to E1 cap upon H1. So this is what you get here. So when you take a grad of U1, so this is the del operator operating on your U1. So this quantity is 0 because U1 and U2 are independent. partial differentiation of u1, the coordinate variable along the u1 coordinate lines, with respect to the coordinate variable along your u3 coordinate line will be 0, because u1 and u2 and u3 are coordinate variables. They are independent of each other. They are always equal to 0. The partial derivative with respect to each other will be 0. u1 will be constant with respect to u2. u1 will be constant with respect to u3. That's what I mean. Right. And here you are, here del u1 and del u1, they will cancel out, will be 1. So u1 cap upon h1 will be grad of u1. So similarly, if you take gradient on u2, you will get e2h2, and gradient of u3, you will get e3h3, just like we are getting it here. Okay, gradient of u1 is e1 cap upon h1. Gradient of u2 is e2 cap upon h2. Similarly, gradient of u3. Now, you can take a cross product between gradient of u2 and gradient of u3. So gradient of u2 is e2 upon h2, cross product with e3 upon h3. h2 and h3 are scalars, so you can just simply put them together like this. However, as I said before, in orthogonal coordinate system, all these unit vectors e1, e2, e3 caps, they are mutually perpendicular. So e2 cross e3 is equal to 1. So this is similar to j cross k is equal to I cap. In a mutually perpendicular unit vectors, j cap cross k cap is equal to I cap. Similar to that, e2 cap cross e3 cap will be equal to e1 cap. So instead of writing e2 cross e3, you can write e1 cap. e1 cap will be equal to h2, h3 multiplied by grad u2 cross product with grad u3. And similar to this, you can also obtain e2 by expression, u3 expression. e2 will be h3 h1 grad u3 cross del grad u2, sorry, grad u1. e3 cap will be h1 h2 grad u1 cross grad u2. Okay. Now, so the first term that we need to deduce is divergence of a1 e1. This again is divergence of a2 e2. Similarly, we should determine third term also. So let us consider the first term, that is divergence of a1 e1 1 cap. So therefore, I can write e1 as h2 h3 gradient of u2 cross u3. So I can write it like this. Okay. So you know that this is a product between two vectors. If you have a product between two vectors, let's say A cross B, you see that this is a cross product, also known as vector product. Why do we say this as a vector product, this cross product as a vector product? The reason is that when you are operating with this operator, that is the cross product here between two vectors, the resultant of this product is also another vector, that is magnitude of A, magnitude of B, sine of the angle between them into n cap, unit vector perpendicular to both A and B vector. That means when you are multiplying two vectors, you are getting a third vector C cap. Okay, you are getting a third vector C cap. So what I want to conclude here is that this quantity is actually vector, certain vector. Now this quantity is a scalar. This quantity is a certain scalar, and this quantity is a certain vector, because a1 is a function of x, y, z. Similarly, h2 and h3 are the magnitudes. So you remember that h2 is what? h2 is magnitude of del r vector upon del u2. And what is h3? That is a scale factor along u3 coordinate line. Scale factor along u3 coordinate line, like I discussed in the previous class, del r upon del u3 magnitude. So they are also scalars. Right. So what you are operating is you are taking divergence on certain scalar and vector, certain scalar and vector. Now, from the vector identity, we know that when we take a divergence on the product of such a scalar and vector, one is scalar here and another is vector. So when you take divergence of scalar and vector product here, the result is gradient of the scalar dot product with the vector plus scalar into divergence of the vector itself. So here in our particular problem here, A1, H2, H3 is scalar. That means here your phi here in this case is equal to A1, H2, H3, and your B vector is equal to gradient of U2 cross product with gradient of U3. As I said, this cross product between the two vector is also another vector. So let us consider this as a vector B. Now, by using this formula, you can say that now divergence of scalar into vector will be equal to gradient of the scalar into dot product with vector. So gradient of the scalar is this is gradient of the scalar dot product with the vector B. Instead of vector B, you write this plus scalar quantity. What is the scalar quantity? A1, H1, A1, H2, H3, divergence of the vector. So divergence of the vector here, right? Divergence of the vector B. Now, we also have another vector identity, which is divergence of A cross B is equal to B dot curl of A minus A dot curl of B. So I don't know if I have deduced this in the notes, but this is simple. You can write, let us consider a Cartesian system. Let us consider a Cartesian system X, Y, Z. In a Cartesian X, Y, Z system, you can write your A vector as A1 I cap plus A2 J cap plus A3 K cap. Your B vector, you can write it as B1 I cap plus B2 J cap plus B3 K cap. Now, if you take a cross product between these two vectors, let us start with the left hand side here. The left hand side is divergence of A cross B. So if you take the cross product between two vectors, A cross B, this will be I, J, K, A1, A2, A3, B1, B2, B3. So you can write the cross product between these two vectors. Oh, this is going to be too lengthy. Equal to I cap A2, B3 minus A3, B2 plus J cap A3, B1 minus A1, B3 plus K cap will be A1, B2 minus A2, B1. So this is the divergence, this thing, A cross B. The left hand side is divergence of A cross B. So you can write divergence of A cross B here. Divergence of A cross B will be divergence of A cross B will be like this. What is divergence? I del upon del X plus J del upon del Y plus K cap del upon del Z dot product with this quantity I A2 B3 I cap A2 B3 A3 B2 plus J cap A3 B1 A3 B1 minus A1 B3 plus K cap A1 B2 A1 B2 minus A2 B1. So if you take a dot product here, you will obtain the left hand side. The left hand side will be I dot I is 1, I dot J is 0, I dot K is 0. Then the left hand side will be del of A2 B3 minus A3 B2 upon del X plus del upon del Y of A3 a3 b1 minus a1 b3 plus del upon del z of a1 b2 minus a2 b1. So this way you can calculate the left hand side. You can start with the right hand side again. That is, if you calculate this minus with this after calculation, then you will obtain this quantity, the same quantity. Okay. So that is how we are going to go about. Oh, hello. Oh, pahu. Class ka nailak lo to ka. Kinula ka. Oh. So this way you can prove this formula also, that is divergence of A cross B equal to B dot. You calculate this quantity like first take the curl of A and then take the product with this, then take the curl of B, then take the product with A, then you subtract them. After subtracting you will get this quantity, which is the left hand side. Okay, so you can continue that. Now that will be too lengthy. Now using this identity, we can write this quantity, that is divergence of grad u2 cross grad u3. Divergence of grad u2 cross grad u3. So divergence of grad u2 cross grad u3 will be, instead of a vector you take the grad u2, instead of b vector you take the grad u3. Okay, then you will get b vector dot product with curl of A. What is your b vector? B vector is grad u3 dot product with curl of A. What is your A here? The gradient of u2 minus A vector, which is your A vector is grad u2. There is a dot product, sorry, grad u2. I forgot to write a dot symbol here. Grad u2 dot product with curl of B. Curl of B is this. And also, I don't know if you have proved this. The proof is, I think they're in my notes also, and you can work it out also. It's quite simple. Curl of a gradient of scalar is also 0 in Cartesian system, which is also applicable in any orthogonal system. In orthogonal coordinate system, curl of a gradient of a scalar is 0. So here in this case, u2 is scalar, u3 is scalar, curl of gradient of u2, curl of gradient of u3, they are both 0. They are both 0 here. Okay. So now if they are both 0, and you see that the second term, this term now becomes, this term now becomes 0. This term now becomes 0. Then we have the first term only. That is divergence of A1 E1 cap is equal to gradient of this. Now, so here what we had was divergence of A1, divergence of A1 E1 cap is equal to gradient of A1 H2, gradient of A1 H2 H3 dot grad of U2 cross grad of U3, grad of U3, grad of U2 cross grad of U3. So grad U2 is E2 cap upon H2, grad U3 is E3 cap upon H3. So I think we have already deduced that. Where is that? Yeah, here grad of U2 is E2 upon H3, grad of U3 is E3 upon H3. We have already deduced that. Now, so therefore you can substitute back here. Grad of U2 is E2 upon H2, grad of U3 is E3 upon H3. Now take the cross product. In orthogonal system, E2 cross E3 will be equal to E1. So instead of E2 cross E3, you can write E1. E1 upon H2 H3. Then in writing the gradient of a scalar, see this quantity is some scalar phi. There is no vector sign here. As you see, this is scalar phi. Gradient of a scalar quantity you can express using the gradient formula, or you can express using your del operator formula. In the previous steps, few minutes ago, we have expressed our del operator. So our del operator is U1 cap upon H1 del upon del U1, right? So E2 cap upon H2 del upon del U2, E3 cap upon del H3 del upon del U3. This is our del operator, right? So you can do it like that. Now E1 dot E1, E1 dot E1 is 1, E1 dot E2 is 0, E1 dot E3 is 0 in orthogonal curvilinear system. So I have already discussed that E1 dot E1 is 1, E1 dot E2 is 0, and E1 dot E3 is 0. This is an orthogonal curvilinear system. So considering that, you will see that E2 dot E1 is 0, E1 dot E3 is 0. So the second term and third term will vanish after taking the dot product with E1 cap here. Then in the denominator you will have H1, H2, H3. So H1, H2, H3, del of A1, H2, H3 upon del of U1. Only the first term will survive here after taking dot product with U1 cap. Now, so you see that this is divergence of A1 E1 cap is equal to this. Okay, and similar to that, you can calculate divergence of A2 E2 cap. You can work it out in your pen and paper. If you follow the divergence of A1 E1 cap calculation, please try to work it out yourself. Using pen and paper, please work out the mathematical form of this divergence of A2 E2. You can see the similar steps. You can follow the similar steps on how we are obtaining divergence of A1 E1 cap. You will arrive at this relation. And similarly, for divergence of A3 E3, you will also arrive at this relation. Now, divergence of A will be divergence of A1 E1 plus divergence of A2 E2 plus divergence of A3 E3. So you add this, this, and this. So the common factor is 1 upon H1 H2 H3, 1 upon H1 H2 H3 multiplied with this, plus multiply this and this. Okay, so this is how we can express divergence of a vector field in in orthogonal curvilinear coordinate system. Orthogonal curvilinear coordinate system. So for a specific orthogonal curvilinear coordinate system, we can determine our H1, H2, H3, U1, U2, U3, and we will discuss that, I think, in the subsequent lectures. For today, I think I should stop here, and I strongly advise everyone to check out my notes and work out the mathematical steps as I suggest. That will help you in understanding, instead of just memorizing the steps for the divergence of A1 E1 calculation. You can work out the divergence of A2 E2 yourself, work out the divergence of A3 E3 cap yourself. Then you will follow all these mathematical steps and you will be familiar with the notations here. So the best thing is to write down, to copy down everything in your own handwriting on your own notebook, and also in working out the remaining mathematical steps here. So if you do that, you will easily understand the topic here. If you don't want to give effort, then you will not follow anything, and it's up to you. You are a college graduate student now, so if you want to learn something out of this course, you have to follow, you have to do as the teacher suggests. If you don't want to learn anything, you will drop out later on. If you don't want to give any effort or any extra effort that is needed for learning purpose, you are already an adult, you are no longer a child. So you have to know what is good for you and what is bad for you. So if you want to learn something out of your college life, and if you want to pass your or obtain your college degree, you have to do as I say. So I will stop my lecture now. I will upload the video again, and you can, after typing your attendance, you can exit the meeting. I will upload the video, but at the same time, please follow the advice and instructions given here. That will help you in learning. So as an adult, I don't want to force you anything, but if you want to make your like your time useful for your future, do as I say, please. Exit the meeting once you finish typing your attendance. Have you finished typing your attendance? If you have typed your attendance, then I will close the meeting session. So I assume everyone has typed your attendance. I will end the meeting. I will end the session.